Hello everyone, welcome back to another show. This time I'll be doing indefinite integration of 2024 GMIN covering both January and April shift. So always we know indefinite integration means they ask less number of questions in GMIN. So I'm doing both together of January and April shift. Okay, quite less number of questions they ask from this topic every year. Even it happened in 2025 also. 2024 also less number of questions because there's more number of questions in definite integration and less in indefinite integration. This has been the trend always from the last several years. We'll discuss the number of questions appeared from different topic and also the questions will discuss indefinite integration of 2024 JMIN covering both January and April shift. Number of questions appeared from different topics is shown here. Integration by method of substitution, there are 3 questions. Integration by parts, 1 question. Integrals of some irrational function, they are not asked any question. Integrals of this type, a cos x plus b sin x by c cos x plus d sin x, 1 question. Integral of this type, 1 by x plus a power m into x plus b power n, where m plus n is 2, m and n are non-zero rational numbers, 1 question. Integral of this type, 1 plus x squared by 1 plus x power 4 is 1 question. Miscellaneous mixing type question 1. Altogether we have 8 questions. 5 questions from April shift, 3 questions from January shift. 8 questions we have altogether. We'll discuss the questions one by one. The first question we have this integral of cosecant power 5x dx is given to be like this. Alpha cot x into cosec x multiplied by cosecant square x plus 3 by 2 plus beta log of mod tan x by 2 plus c. Alpha, beta, real number. C is a constant. Want to find 8 times alpha plus beta. So integral of cosecant power 5x will start. Cosecant power 5x. To integrate cosecant power 5x, I am going to use integration by parts. I am going to split cosecant power 5x as cosecant cube x into cosecant square x. Okay. I'll split this as, take the integral as I. I is equal to integral of cosecant power 5x dx. We'll split this cosecant power 5x as cosecant cube x into cosecant square x. Cosecant cube x into cosecant square x. And we'll take cosecant square x as second function. Whichever function is easy to integrate, no, that I'll take it as second function. Integrating cosecant square x is much easier than integrating cosecant cube x. So I'll take cosecant square x as second function and cosecant cube x as first function. Because you know that integral of cosecant square x is minus cot x. So I'll take this as second function. Okay. This is my first function, second function. I am applying integration by parts. Integral of first into second is first function keep as it is, integrate the second, minus integral of integrate the second, differentiate the first. Okay. This is my first function. This is my second function. Integral of first into second. First function keep as it is. First function keep as it is. Integrate the second function. Integral of cosecant square x is minus cot x. So minus cot x. Minus integral of cosecant square x is minus cot x into derivative of cosecant cube x. Derivative of cosecant cube x is like you differentiate x cube by using chain rule. Derivative of x cube is 3x square. Likewise differentiate cosecant cube x. 3 cosecant square x into derivative of cosec x, which is minus cosec x cot x. So derivative of cosecant cube x is 3 cosecant square x. 3 cosecant square x into derivative of cosec x, which is minus cosec x cot x. Multiplied by, I wrote in the next line, okay. So this is equal to how much? Minus cosecant cube x into cot x. Minus cosecant cube x into cot x. Minus into minus into minus is minus. 3 you can keep outside. Cosecant square into cosecant becomes cosecant cube. Cot into cot is cot square. So I am getting integral of cosecant cube x into cot square x. Correct? Cot square you can write cosecant square minus 1 using the identity. 1 plus cot square x is cosecant square x. So cot square x I write cosecant square minus 1. Okay? This is equal to minus cosecant cube x into cot x. Minus 3 into integral of cosecant cube x into cot square x I'll write cosecant square x minus 1 dx. Cot square is cosecant square minus 1. Multiply this. what we get is equal to minus cosecant cube x into cot x minus 3 cosecant square into cosecant cube becomes cosecant power 5x integral of cosecant power 5x minus into minus is plus 3 into integral of cosecant cube x. Okay, and this part is nothing but I. We started with I, integral of cosecant power 5. Again I'm getting this same as what we started. So left hand side we have I is equal to minus cosecant cube x into cot x minus 3 into integral of cosecant power 5x is I. So this is I, and this part I'll do it separately. 3 into, I'll call this as I1, okay, 3 into integral of cosecant cube x, that is I1 I'll call. I'll find out this separately. For this to integrate, no, I'll do it by parts again. I'll add one page and do it in the next page and substitute back here later. So integral of cosecant cube x I'll consider. Let I1 is equal to integral of cosecant cube x. Integral of cosecant cube x and integral of secant cube x should be done by parts. Okay, both are very standard. So integral of cosecant cube x. Cosecant cube x we can write it as cosecant square x into cosec x or cosec x into cosecant square, right? Easier function always you take it as second function. Cosecant square is easy to integrate. So I'll take cosecant square x as second function. So this is my first function and this is my second function. I'm applying integration by parts for this. Integral of first into second. First function keep as it is, integrate the second. Minus integral of integrate the second, differentiate the first. So this is equal to cosecant x into integral of cosecant square x is minus cot x minus integral of integrate the second function minus cot x into derivative of first function. Derivative of cosec x is minus cosec x into cot x minus cosec x into cot x. Correct? First function keep as it is, integrate the second minus integral of integrate the second, differentiate the first. Derivative of cosec x minus cosec x cot x. So what we get is this is equal to minus cosec x into cot x minus into minus into minus is minus. Here cot x into cot x is cot square x. So what we get is cosec x into cot square x. Cot square x is cosecant square x minus 1. Correct? I'll use the identity here. Minus cosec x into cot x minus integral of cosec x into cot square x, I'll write cosecant square x minus 1. Now multiply this. I'll get cosecant cube x, which is nothing but I1 we started with. So minus cosec x into cot x minus cosec x cot x minus integral of, open the bracket, cosecant cube x. Correct? Minus into minus is plus integral of cosecant x. Correct? This is nothing but I1 we started with. I1 is integral of cosecant cube x. So this is equal to minus cosec x into cot x minus I1. Left hand side also we have I1. Minus I1 taken that side. I1 plus I1 becomes 2I1. And integral of cosec x we know. Log of mod cosec x minus cot x. One formula. So another formula is that log of mod tan x by 2. I'll be using the second formula. Because in the question you see, they're given in terms of log of mod tan x by 2. So I'll use the second formula. Okay. I'll use the second formula for integral of cosec x. Log of mod tan x by 2. Of course, we can add a constant c now at this stage or later, no problem. I1 plus I1 minus I1 taken to left hand side becomes plus I1. I1 plus I1 is 2I1. 2I1 is equal to 2I1 is equal to minus cosec x into cot x plus log of mod tan x by 2. Divide the entire equation by 2. So we get I1 is equal to I1 is equal to minus half cosec x into cot x. Correct? Plus half log tan x by 2. Half log mod tan x by 2. This I am going to substitute. I1, what I got here, I am going to substitute integral of cosecant cube x. Once again I will explain. Cosecant cube x, you write cosec x into cosecant square x and take cosecant square x as second function. Whichever function easy to integrate, take it as second function. So first function is cosec x, second function is cosecant square x. Integrate by parts. Integral of first into second. First function keep as it is, integrate the second, minus integral of, integrate the second, differentiate the first. Integral of cosecant square x is minus cot x. Integral of cosecant square x is minus cot x. Derivative of cosec x is minus cosec x cot x. Minus into minus into minus is minus. Cot x you keep, cot x into cot x becomes cot square x. And cosec x into cot square x I get. Cot square write cosecant square minus 1. Using the identity we have 1 plus cot square x equal to cosecant square x. Multiply it. Multiply. And this is again same as I1. So this becomes minus I1. Take it to left hand side, becomes plus I1. I1 plus I1 is 2I1. So divide by 2. I'll get like this. Minus half cosec x cot x plus half log mod tan x by 2. This I'm going to substitute in I1. Okay. I1 I got 3 times. This is I1. I1 I'll substitute. This is my I1. I'll substitute here itself. I1 I got. That is integral of cosecant cube x. What I got? Minus half cosec x cot x. Minus half cosec x cot x minus half cosec x cot x plus half log mod tan x by 2 plus half log mod tan x by 2. This minus 3I take it that's it becomes plus 3I. I plus 3I becomes 4I. Correct? So I'm getting 4I is equal to 4I is equal to minus cosecant cube x into cot x. Correct? Minus 3 by 2. I should get in this form. Beta log tan x by 2. Correct? I'm getting beta is 3 by 2 then comparing. Correct? 3 by 8 it becomes after dividing by 4. So this is minus 3 by 2 cosec x into cot x minus 3 by 2 cosec x into cot x plus 3 by 2 log of mod tan x by 2. 3 by 2 log of mod tan x by 2. Divide the entire equation by 4. I is equal to how much? Also I can take cosec x cot x common here. Correct? As we have cosec x into cot x I can take common. So that I get in the form of cosecant square x plus 3 by 2. Correct? You can divide by 4 first. We'll divide the entire equation by 4. I is equal to, I'll get minus 1 by 4 cosecant cube x into cot x. This will be minus 3 by 8 cosec x into cot x plus 3 by 8. 3 by 8 log of mod tan x by 2. Finally, I can add a constant c at this stage. Everything is complete. I'll add a constant c. And I'll write in this form so that I can compare. I want cosecant square x plus 3 by 2 inside the bracket. So you take minus 1 by 4 cosec x cot x common. From the first two terms, you take minus 1 by 4 cosec x cot x common. So I'll write in the next page. Oh, here also don't have space. I'll write in the next page. One more page I'll add. Therefore, I is equal to what? The given integral I is equal to. Here I'll take minus 1 by 4 cosecant square x common. Minus 1 by 4 cosec x cot x common. Correct? Minus 1 by 4 cosec x into cot x is taken out. Minus 1 by 4 cosec x into cot x is taken out. Correct? Minus 1 by 4 cosec x into cot x is taken out. So what remains is cosecant square x plus 3 by 2 as we got. Correct? Cosecant square x plus 3 by 2. So that when I multiply these two I get minus 1 by 4 cosecant cube x cot x minus 3 by 8 cosec x cot x. Correct? That is what we have. Minus 1 by 4 cosecant cube x cot x minus 3 by 8 cosec x into cot x. Next what we have is 3 by 8 log of mod tan x by 2. In this form I am getting 3 by 8 log of mod tan x by 2. 3 by 8 log of mod tan x by 2. plus a constant c is equal to, now we can compare with that form what is given there. Given alpha cot x cosec x, alpha cot x, alpha cosec x cot x, right? Both same. Into cosecant square x plus 3 by 2, cosecant square x plus 3 by 2 plus what is given? Beta log of mod tan x by 2. Beta log of mod tan x by 2 plus a constant c. Correct? So if we compare, alpha is minus 1 by 4, beta is 3 by 2, 3 by 8. This was given in the question, right hand side. Comparing, we get comparing we get alpha is minus 1 by 4 and beta is 3 by 8. What we need to find is 8 times alpha plus beta, numerical type question asked. Therefore required is 8 times alpha plus beta. 8 into minus 1 by 4 plus 3 by 8. 8 into minus 1 by 4 is minus 2. 8 into 3 by 8 is 3. Minus 2 plus 3, 1. Hope it's clear. Answer is 1. 8 times alpha beta is 1. Learn how to integrate cosecant power 5x and learn how to integrate cosecant cube x. Of course, you can reduce a reduction formula for all these things, but it takes more time. Better to do this method only. Can't remember everything, correct? So whatever is possible to remember, only remember that. Because in a 3 hours exam, combining all physics, chemistry, maths, only 3 hours exam you're writing and you're studying for 2 years, correct? 2 years is quite long time and you're answering that entire 2 years what you learned in 3 hours. 3 hours exam, that too, 3 subjects. Just 1 hour for maths, 1 hour for physics, 1 hour for chemistry. So everything can't remember and go. So whatever is possible to remember, only such things remember. Because you try to remember everything, you'll forget everything. That's the thing. So don't try to remember which is unwanted things. Which is not possible to remember, you don't remember. Only which is more, which is highlighted, only such things you can remember it. So integration by parts, nobody can forget this formula. Lifetime you can remember this. Integration by parts. Integral of first into second. First function keep as is, integrate the second. Minus integral of integrate the second, differentiate the first. That is a formula which can be remembered for quite long time. Cannot forget it. Such a useful formula here and there, correct? So cosecant power 5, cosecant cube into cosecant square. Integration by parts. At some stage I am going to get integral of cosecant cube x. And again integrate this by parts. That is shown here. This part is shown in the next page here. Okay? Shown here in detail. And the last part, which is this part, a continuation of this is shown here. Okay, I'm comparing with alpha cosec x cot x into cosecant square x plus 3 by 2 plus beta log of mod tan x by 2. I'm using the second formula for integral of cosec x. Integral of cosec x, actually there are two formulas. One is log of mod cosec x minus cot x. Another formula is log of mod tan x by 2. I'm using second formula for this. Integral of secant x also, there are two formulas. One is log of mod secant x plus tan x. Another one is log of mod tan pi by 4 plus x by 2. Okay. So better to learn both the formulas. For competitive exam, they can ask in any form. Okay. So they kept in this form. So I'm using the second formula for integral of cosec x. Okay. Hope it's clear. This was the answer. In detail, we have done it. Move on to the next one. Question number 2. Integral of 1 by a square sin square x plus b square cos square x is given as 1 by 12 tan inverse of 3 tan x plus a constant. Want to find the maximum value of a sin x plus b cos x. After integrating, you need to find the maximum value of this expression. We know the maximum value of a sin x plus b cos x is root of a square plus b square. So integrate this. We know the method of integrating this type. Integral of 1 by a square sin square x plus b square cos square x. Integrals of this type can be done by dividing numerator and denominator by b square cos square x. You can divide by b square cos square x. Or else you can divide by a square sin square x. Any method you can do. But here answer is given in terms of 3 tan x, you see. That means, derivative of tan is secant square. So I'll express in terms of tan and secant square. So the derivative of tan is secant square. So I'll divide numerator and denominator by b square cos square x, or just cos square x was enough. I can divide numerator denominator by just cos square x. Take the integral as I. Let I is equal to integral of 1 by a square sine square x, 1 by a square sine square x plus b square cos square x. I'll divide numerator and denominator by cos square x. Divide numerator and denominator by cos square x. Numerator and denominator by cos square x. What again? I is equal to, this is 1 by cos square x. 1 by cos square x is secant square x. Divided by a square into sine square by cos square is tan square x. Plus b square cos square x by cos square x 1 b square. Dividing numerator and denominator by cos square x. Again like this. Now I'll take t is equal to a tan x. Derivative of a tan x is a secant square x. Put t is equal to a tan x. Put t is equal to a tan x. Put t is equal to a tan x. And differentiate this. dt by dx. Derivative of a tan x is a into secant square x. So dt by a is equal to how much? Dt divided by a is equal to secant square x into dx. Secant square x into dx is dt by a. Dt by a means keep 1 by a outside. 1 by a outside. Integral of dt divided by, I put t is equal to a tan x. So a square tan square x is t square. So this becomes t square plus b square. dt means 1 dt. Integral of 1 by t square plus b square. 1 by integral of 1 by x square plus a square is 1 by a tan inverse x by. Correct? Integral of 1 by t square plus b square is 1 by b tan inverse of t by b. So this becomes 1 by a is constant, keep as it is. Integral of dt means 1 dt. So integral of 1 by t square plus b square is 1 by b tan inverse of t by b plus a constant c. T you substitute back. T is a tan x. Correct? So this becomes 1 by ab tan inverse of, what is my t? T is a tan x. Substitute back. A tan x divided by b plus a constant c. Constant c. They given already the answer as 1 by 12 tan inverse of 3 tan x. What is given? I is given. I is equal to, I is given to be equal to 1 by 12 tan inverse of 3 tan x. 1 by 12 tan inverse of, what is given? 3 tan x. So this and this you compare. If we compare these two, I get AB is 12 and A by B is 3. Comparing, we get AB is 12. Comparing, we get AB is equal to 12. AB is equal to 12 and A by B equal to 3. A by B equal to 3. AB is 12, A by B is 3. Solve these two equations, get the values of A and B and substitute A and B. Then you can find the maximum value of A sin x plus B cos x. So A is 3B now from this. A is 3B. Correct? That you can substitute in this. A is 3B. A is 3B. 3B into B becomes 3B square. Correct? 3B square is 12. So B square is 4. I'll take B is plus or minus 2. I can take a positive value, assume that B is positive, or else you can write both the values, no problem. So B square is 4. A is 3B from this. A is 3B substitute. 3B into B, 3B square. 3B square is 12, means B square is 4. Correct? B square is 4. B square is 4, means B is plus or minus 2. A is 3B, so A is plus or minus 6. is plus or minus 6. 3 into 2, 6. So I want to find the maximum value of this. A sin x plus b cos x. A is plus or minus 6. B is plus or minus 2. Want to find maximum value of this expression. We know maximum value of a sin x plus b cos x is root of a square plus b square. Correct? So I'll be using that concept. So maximum value of this is root of 6 square is 36 and 2 square is 4. 36 plus 40, root 40 is the answer. Maximum value. Okay. If you want, you can write the steps in the next page. Maximum value you want. Correct. Maximum value. We got A equal to plus or minus 6. B is plus or minus 2. Therefore, the expression A sin x plus B cos x becomes A sin x plus B cos x becomes equal to plus or minus 6 into sin x plus or minus 2 into cos x. So, maximum value of A sin x plus B cos x. We know that maximum value of A sin x plus B cos x is root of A square plus B square. Minimum value is minus root of A square plus B square. We know. Therefore, maximum value of A we got plus or minus 6. No? So, maximum value of plus or minus 6 into sin x plus or minus 2 into cos x is equal to root of plus or minus 6 square is 36 plus or minus 2 square is 4, which is root 40. Root 40 is the answer. Maximum value of A sin x plus B cos x. Root 40. Question asked on 6th of April, second shift, JMN 2024. Please make a note. Standard integral. This is dividing numerator and denominator by cos per x. Reducing it to standard form because derivative of tan is secant square. Answer is given in terms of tan here. So I want to express in terms of tan. That's why I'm dividing by cos per x. If it was given in terms of cot here, then I can divide numerator and denominator by sin square x and we'll get in terms of cot and cosec. Derivative of cot x is minus cosecant square x. That method is suitable if it is in terms of cot here. Now it's already given in terms of tan. So I'm dividing numerator and denominator by cos per x, reducing it to the standard form and integrating it. Hope it's clear. Move on to the next one. Question number 3. I of x is given like this. Integral of 6 by sin square x into 1 minus cot x the whole square. With respect to x, I of 0 is given to be equal to 3, I of pi by 12 have to find out. So here you can see that 1 minus cot x and derivative of cot x is cosecant square x, derivative of minus cot x is plus cosecant square x, also sin square x can be taken up, becomes cosecant square x. So suitable to integrate by method of substitution because derivative of minus cot x is cosecant square x. You can see minus cot x in the question, you can see cosecant square x in the question, visualize both. Correct. So easily I can tell this can be done by integration by method of substitution. So I of x is equal to I can write it as this sin square x, we take it to numerator, becomes cosecant square x. 6 will keep outside. Correct. Integral of cosecant square x divided by 1 minus cot x the whole square. 1 minus cot x the whole square. 6 you keep outside. 1 by sin square x is cosecant square x. 1 minus cot x whole square. Put t equal to 1 minus cot x. Put t is equal to 1 minus cot x using the method of substitution. Differentiate this. dt by dx. Derivative of 1 is 0. Derivative of cot x is minus cosecant square x. Minus of minus becomes plus cosecant square x. So dt is equal to cosecant square x into dx. Cosecant square x into dx is dt. 6 is kept outside. Hope it's clear. 6 is constant kept outside. 1 by sin square written as cosecant square x. And cosecant square x into dx is dt here. So this integral becomes 6 into integral of dt divided by 1 minus cot x is taken as t. So t square. dt means 1 dt. dt means 1 dt. Integral of 1 by t square. Integral of 1 by t square with respect to t is minus 1 by t. So this will be 6 into minus 1 by t. So minus 6 by t. Minus 6 by t plus c. Which is equal to minus 6 divided by, what is the t substitute? T is 1 minus cot x. T is 1 minus cot x plus a constant c. Constant c can be found using a given condition I of 0 equal to 3. Given that I of 0, so put x equal to 0. Put x equal to 0. Cot 0 is not defined, correct? Tan 0 is 0. Cot 0 is not defined, not even infinity. 6 by infinity is 0. Put x equal to 0. So I am getting I of 0 is equal to minus 6 divided by 1 minus cot 0 plus a constant c. I of 0 is given to be equal to 3. Correct? I of c is given to be equal to 3. Cot 0 is infinity. Correct? 6 by infinity is 0. So this becomes 0. 0 plus c. I am getting the constant c equal to 3. Constant c is equal to 3. So my I of x I got. Constant c I can substitute. Therefore I of x equal to, I of x is equal to minus 6 by 1 minus cot x minus 6 divided by 1 minus cot x plus a constant c, we got 3. Now we need to find I of pi by 12. Put x equal to pi by 12. Cot pi by 12. Pi by 12 in terms of degrees is 15 degree. Pi means pi radians 180. 180 by 12 is 15 degree. Cot 15 degrees 2 plus root 3. Tan 15 degrees 2 minus root 3. Cot 15 degrees 2 plus root 3. So I of pi by 12. I of pi by 12 is going to be equal to minus 6 divided by 1 minus cot pi by 12. Cot pi by 12 is 2 plus root 3 plus a constant 3. Simplify this. Minus 6 divided by 1 minus 2 is minus 1. Minus 1 minus root 3. Minus of 1 plus root 3 I can write. Minus of 1 plus root 3 plus 3. Minus minus cancels. 6 by 1 plus root 3. I can rationalize that. 6 by 1 plus root 3 is 6 by 1 plus root 3 same as root 3 plus 1. So if you multiply and divide by root 3 minus 1, what I am getting here? Multiply and dividing by root 3 minus 1. 6 into root 3 minus 1. Denominator is a plus b, a minus b, a square minus b square, root 3 square, 3 minus 1, 2. 2 ones are 2 3s are. I'll get 3 times root 3 minus 1, which is 3 root 3 minus 3. 3 root 3 minus 3, this part. Minus minus got cancelled. I'm getting this as how much? Is equal to how much? Minus minus got cancelled. 6 by 1 plus root 3. I'm getting 3 root 3 minus 3. So 3 root 3 minus 3. This much I got. 6 by 1 plus root 3 plus 3. So answer is 3 root 3. 3 root 3. Option C. Question asked on 8th of April, first shift, JEE Main 2024. Quite simple question. Using method of substitution, we get the answer. Okay. Learn the value of cot pi by 12, which is 2 plus root 3. Tan pi by 12 is root 2 minus root 3. Cot pi by 12 is 2 plus root 3. 1 minus 2 is minus 1. Minus 1 minus root 3. Minus of 1 plus root 3. Minus cancels. Multiply and divide by root 3 minus 1 and simplify it, get the answer. 3 root 3 minus 3 plus 3. Minus 3 plus 3 cancels. 3 root 3. Move on to the next one. Fourth one. Integral of 1 by 5th root of x minus 1 power 4 into x plus 3 power 6. This is of the application of quotient rule. We take integral of the type 1 by x plus a power m into x plus b power n, where m and n are rational numbers, m plus n is 2. Observe that power of x minus 1 and power of x plus 3, if you add, you get 2. Correct? So take the integral as I. Take the integral as I. I is equal to integral of 1 by 5th root means to the power 1 by 5, correct? So x minus 1 power 4 into x plus 3 power 6 whole to the power 1 by 5, right? X minus 1 to the power 4 into x plus 3 power 6. X plus 3 to the power 6 whole to the power of 1 by 5 is equal to integral of 1 by, this is x minus 1 to the power 4 to the power 1 by 5, that is 4 by 5. This is x plus 3 to the power 6 to the power 1 by 5. That is, powers gets multiplied 6 by 5. You observe that 4 by 5, 6 by 5 both are rational numbers, and 4 by 5 plus 6 by 5, 10 by 5 is 2. Sum of the powers is 2. So I will use quotient rule. The method of doing this problem is there are two methods. I can multiply and divide in the denominator. I can multiply and divide by x plus 3 power 4 by 5, or multiply and divide by x minus 1 power 6 by 5. Any method you can do. I'll multiply and divide by x plus 3 power 4 by 5 in the denominator. Okay. Any method you can apply. So integral of 1 by, what we have is x minus 1 to the power 4 by 5 already we have. I'm dividing by x plus 3 power 4 by 5. X plus 3 power 4 by 5. And to balance it, multiply by the same thing. X plus 3 power 6 by 5. Here it is x plus 3 power 4 by 5. Multiply and divide by x plus 3 power 4 by 5. Here multiplying means adding the powers. 6 by 5 plus 4 by 5. You can add the powers. 6 by 5 plus 4 by 5. 10 by 5 2. And this I can write it as integral of 1 by, this is x minus 1 by x plus 3 whole to the power 4 by 5. Correct? Whole to the power 4 by 5. This is x plus 3 the whole square. Now we can put t is equal to x minus 1 by x plus 3. Method of substitution and as application of quotient rule type of question. So put t equal to what? X minus 1 divided by x plus 3. Derivative of this takes the form ax plus b by cx plus d. Derivative of this is ad minus bc by denominator square. Shortcut. No need to apply quotient rule. Directly I can give the answer. dt by dx. From this, what is dt by dx? dt by dx. Applying shortcut method, time saving result I can call ad minus bc. 1 into 3. 3 minus minus 1. 3 crisscross applesauce. 1 into 3. 3 minus minus 1. 4. 4 divided by x plus 3 the whole square. Using this, y is equal to ax plus b by cx plus d. If it is ax plus b by cx plus d, derivative is ad minus bc by denominator square. That is what I use. dy by dx. In this case, dy by dx is equal to what? ad minus bc by denominator square. ad minus bc divided by cx plus d the whole square. This is the formula. Okay, I used 1 into 3 minus of minus 1. 3 plus 1. 4 by denominator square. You can see 1 by x plus 3 the whole square, or dx by x plus 3 the whole square. Cross multiply. dx by x plus 3 the whole square is dt by 4. dt by 4 means keep 1 by 4 outside. 1 by 4. Integral of 1 by, this part I wrote, dt by 4. dt you can write here. Divided by, this is t power 4 by 5. t power 4 by 5, take it up. This becomes t power minus 4 by 5. And use integral of x power n formula. Integral of x power n is x power n plus 1 by n plus 1. So this will be 1 by 4 into integral of t power minus 4 by 5. So t power minus 4 by 5 plus 1 by minus 4 by 5 plus 1. Minus 4 by 5 plus 1 is 1 by 5. t power 1 by 5 divided by 1 by 5 plus a constant c. This 5 goes up, becomes 5 by 4. 5 by 4. t is substituted. T is x minus 1 by x plus 3. To the power 1 by 5 plus a constant c. And you compare with this. Compare with this. A into alpha x minus 1 by beta x plus 3 to the power b. Correct? Comparing with a into alpha x minus 1 divided by beta x plus 3 to the power b plus a constant c. If we compare, a is 5 by 4, b is 1 by 5, alpha is 1, coefficient of x, beta is coefficient of x 1. So if we compare I'll write the values here. A is 5 by 4. A is 5 by 4. Alpha is 1. Beta is 1. Correct? Alpha 1, beta 1. B is 1 by 5. B is 1 by 5. I got everything. Constants. Comparing these two. Want to find alpha plus beta plus 20 AB. Alpha is 1. Beta is 1. Plus 20 times AB. A is 5 by 4. A is 5 by 4. B is 1 by 5. Correct. 5 cancels. 4 ones are 4 5s are. 5 plus 1 plus 1. Answer is 7. Correct. A got 5 by 4. Substitute A is 5 by 4. B is 1 by 5. 5 cancels. 4 ones are 4 5s are. 5 into 1 5. 5 plus 1 plus 1. 5 plus 2 7. Numerical type question asked on 8th of April, second shift, JEEM in 2024. Please make a note. It's very standard. This type of question is asked even in 2025 also. So very important method. Please learn this. Application of quotient tool and learn this shortcut. Very quite useful to save the time. Okay, time saving result. So you can, all these problems can be done within 1.5 minute, not more than that. We can do it after a bit of practice. Quite a lot of practice is required. Okay, then only it's possible to solve the problem in less time. We should solve in less time. That is also important. Not taking more time in solving, because we can't finish the paper if you do like that. So this is a very standard question. Many times you can see this type of question. Minimum 3 or 4 times this type of question has appeared in the previous years. Okay, so please practice it. It's an application of quotient tool. Ax plus b by cx plus d. Derivative is ad minus bc by denominator square. Move on to the next one. Question number 5. Integral of 2 minus tan x by 3 plus tan x with respect to x. Given like this. Alpha, beta, gamma I have to find out. Alpha plus gamma by beta I have to find out. So this is, I can write tan as sine by cos. Take the integral as I first and write tan as sine by cos. Integral of 2 minus tan x. 2 minus tan x divided by 3 plus tan x. This is equal to, I'll write tan as sine by cos and take LCM. Wherever there is tan, write sine by cos. If you write tan as sine by cos and take LCM, this will be 2 minus sine x divided by cos x divided by 3 plus tan x, right, sine x divided by cos x. Taking LCM and simplifying this, what do you get? 2 cos x minus sine x divided by cos x will cancel out in the denominator and numerator. This will be 3 cos x plus sine x. This integral is of the type a cos x plus b sin x by c cos x plus d sin x. There is a method actually for this. I won't be using that method. I'll use direct shortcut method for this. Time saving result I can call. So actual method, I'll just tell you what is the method of doing this. Okay, but I'll be using the time saving result and get the answer. The method of integrating this a cos x plus b sin x by c cos x plus d sin x. Integrals of this type should be done by taking numerator is equal to lambda into denominator plus mu into differentiation of denominator. The method is write numerator is equal to lambda into denominator plus mu into differentiation of denominator. This is the method actually. Okay. Numerator is a cos x plus b sin x. Lambda into denominator plus mu into derivative of denominator. This is the method actually to integrate. What we'll do is, I'll use a shortcut method or time saving result. It's very standard. It's better to remember this. Otherwise it takes more time. You have to find lambda and mu from this. You have to equate the coefficient of cos x. You have to equate the coefficient of sin x. All those things. If you want to do the actual method also. The time saving result I'm going to use this integral of this type. I'll write the method here. Integral of a cos x plus b sin x. A cos x plus b sin x divided by c cos x plus d sin x. C cos x plus d sin x. Integral of this type is equal to AC plus BD by c square plus d square. AC plus BD divided by c square plus d square into x plus AD minus BC divided by c square plus d square into log of mod denominator, log of mod c cos x plus d sin x plus a constant c. This is the method. Okay, this is a time saving result, and this is a method if you want to do the method also separately. So now I'll be using this and getting the answer very easily. I want to compare this form. I need to find alpha, beta, gamma. Okay, so A is 2, compare these two. If we compare these two, A is 2, B is minus 1, C is 3 and D is 1. So I'll be using this formula. AC plus BD by C square plus D square into x plus AD minus BC by C square plus D square log of mod denominator. That's the answer. I don't have to look at that also. Directly I'll write. So this is equal to AC plus BD. 2 into 3, 6. AC plus BD. BD is minus 1. Divided by C square plus D square. 3 square plus 1 square. 3 square is 9. 1 square is 1 into x plus AD minus BC. 2 into 1, 2 minus 3 into minus 1 minus 3 divided by c square plus d square 9 plus 1 into log of mod denominator. Log of mod denominator is what? 3 cos x plus sin x. That's the answer. Over. Plus a constant c. That's equal to, this is 5 by 10, which is half. Half x. This is also 5 by 10, half into log of mod 3 cos x plus sin x plus the constant c. Compare what is given. They taken half common, right? Half we can take outside. Half we keep outside. What remains is x plus log of mod 3 cos x plus sin x. Same as sin x plus 3 cos x. I can interchange it, right? No problem. Sin x plus 3 cos x plus a constant c. Now compare. Half into, half is there, alpha x, comparing these two, I get alpha equal to 1, alpha is equal to 1. Here log of mod beta sin x plus gamma cos x, so beta is 1, coefficient of sin x is beta, coefficient of sin x 1 inside the mod, beta is 1. Gamma how much? Gamma is coefficient of cos x, coefficient of cos x is 3, so gamma is 3. Want to find alpha plus gamma by beta. Required is alpha plus gamma divided by beta. Alpha how much? 1. Alpha is 1. Gamma is 3. Beta is 1. So 1 plus 3. Answer is 4. 1 plus alpha is 1. Gamma is 3. Beta is 1. 1 plus 3 by 1. 3 by 1 is 3. 3 plus 1, 4. Question answer. 9th of April, first step. JEE in 2024. If you want to do the actual method also. The actual method is this. Take numerator equal to lambda into denominator plus mu into derivative of denominator. This is the actual method. From here I can start the actual method. Integral of 2 cos x minus sin x by 3 cos x plus sin x. You to use this step and determine the values of lambda and mu. Lambda and mu can be got by equating coefficient of sin x and equating coefficient of cos x. And getting the, solving the two equations will get lambda and mu. Then the rest everything is same. If you want to do this method, the actual method also will show. 2 cos x minus sin x by 3 cos x plus sin x. Consider integral of 2 cos x minus sin x. Integral of 2 cos x minus sin x divided by 3 cos x plus sin x. Doing the actual method. Correct? 2 cos x minus sin x by 3 cos x plus sin x. Take numerator is equal to lambda into denominator plus mu into derivative of denominator. This is numerator 2 cos x minus sin x is equal to lambda into denominator is 3 cos x plus sin x plus mu into derivative of denominator. Derivative of 3 cos x is minus 3 sin x plus derivative of sin x is cos x. Equating the coefficient of cos x and sin x. Equating coefficient of cos x, what do we get? Equating coefficient of cos x. Equating coefficient of cos x, what do we get? Left hand side is 2. Here 3 lambda. Coefficient of cos x is mu here. Equating coefficient of sin x. Equating coefficient of sin x. Coefficient of sin x. What is coefficient of sin x? Minus 1. Coefficient of sin x is lambda here. Coefficient of sin x is minus 3 mu. Correct? Minus 1 equal to lambda minus 3 mu. Solve the two equations. You can multiply the second equation by 3. So this will be minus 3 is equal to 3 lambda minus 9 mu. And that equation keep as it is. 2 is equal to 3 lambda plus mu. Subtract. Minus. This will cancel. Minus 3 minus 2 minus 5. This is minus 10 mu. So I'll get mu is equal to half. Mu is equal to minus 5 by minus 10, which is half. Mu is equal to half is substitute. Put mu is equal to half in equation. The first equation, 2 is equal to 3 lambda plus mu. Correct? 2 is equal to 3 lambda plus mu is 1 by 2. 2 minus half is 3 by 2. 3 by 2 is equal to 3 lambda. So I get lambda is equal to 1 by 2. Lambda is 1 by 2, mu is 1 by 2. Same thing we got. And 1 by 2, 1 by 2. This is 1 by 2, 1 by 2. Then substitute back and then integrate. You'll get the answer. Okay. Lambda is substitute here. Mu you can substitute here. Therefore, numerator becomes, numerator is equal to, lambda is 1 by 2. Mu is 1 by 2. Correct? 1 by 2 into denominator plus 1 by 2 into derivative of denominator. I got like this. Correct? That you're going to substitute in the numerator. That is lambda is here, mu is here. That you're going to substitute there. And separate the terms and integrate. You'll get the answer. Therefore, this integral becomes, what is 2 cos x minus sin x? Numerator I'm substituting. Lambda is half. Half into 3 cos x plus sin x. 3 cos x plus sin x. Mu is how much? Mu is also half I got. Half into minus 3 sin x plus cos x. This entire thing is divided by 3 cos x plus sin x. Here, separate the terms. 3 cos x plus sin x is going to cancel. Integral of half I'll get. Correct? This is I equal. The integral is I. Therefore, I becomes equal to integral of this by this cancels. Integral of half with respect to x plus half you keep outside. What we have? This by this. Minus 3 sin x plus cos x. Minus 3 sin x plus cos x divided by 3 cos x plus sin x. Integral of half is half into x. Here half into. This is the integral of f dash by f. If you differentiate the denominator, we get the numerator because you have set the equation like that. Derivative of 3 cos x minus 3 sin x. Derivative of sin is cos. Integral of f dash by f. Integral of f dash by f is log of denominator. So I get log of mod denominator. Log of mod 3 cos x plus sin x. That is what we got. This much of work you should do actually. So much of time consuming, correct? So we can use this time saving result directly, we can get the answer. This is what we got, half x plus half log of mod 3 cos x plus sin x. Same thing I got here, correct? So it's better to learn this time saving result. Integral of a cos x plus b sin x by c cos x plus d sin x is ac plus bd, ac plus bd by c square plus d square into x plus AD minus BC by C square plus D square log of mod denominator. Quite easy. Okay. Question asked on 9th of April, first shift, JEE Main 2024. Move on to the next one. The integral of this is equal to which of the option is satisfying, you should see. Which of the option is right, you should see. So integral of this is given x power 8 minus x squared by x power 12 plus 3x power 6 plus 1 the tan inverse of x cube plus 1 by x cube. Sometimes you can't identify how to start the problem. Okay, by practicing more and more number of questions, you'll get the idea how to do. So what I'll do is I'll put t equal to tan inverse of x cube plus 1 by x cube here. Method of substitution. Options will help you. See, log of mod tan inverse is everywhere. Log of mod tan inverse. That means it takes integral of f dash by f. Integral of f dash by f is log f. I'll take t is this. In the denominator f dash by f. So this should be your f dash. Correct? So I'll looking at the options, I'll get a little hint. So I'll put t equal to tan inverse of x cube plus 1 by x cube and see what is the derivative of that. Put t is equal to tan inverse of x cube plus 1 by x cube. From this dt by dx. Derivative of tan inverse x is 1 by 1 plus x square. So 1 by 1 plus x cube plus 1 by x cube the whole square into derivative of x cube plus 1 by x cube. Derivative of x cube is 3x square. Derivative of 1 by x cube is minus 3 by x power 4. Derivative of x cube is 3x square. Derivative of 1 by x cube is minus 3 by x power 4. Derivative of 1 by x power n formula, you know. Derivative of 1 by x power n is what? Minus n by x power n plus 1. Derivative of 1 by x power n is minus n divided by x power n plus 1. Using that. So now here you can expand this and simplify and go on simplified further and further. 1 by, this is 1 plus, here x cube square will be x power 6. This is 1 by x power 6 plus 2 EV part, 2 into x cube into 1 by x, that is 2. Here this is 3 common, no? 3 is common. I can take 3 common here. What is left is x square minus 1 by x power 4. Take x power 6 as common denominator. 2 plus 1 is 3. X power 6 common, that goes to numerator. That is 3 into x power 6 divided by 2 plus 1 3. I'll get 3x power 6. X power 6 into x power 6 becomes x power 12 plus 1. Correct? Taking LCM as x power 6 and x power 6 taken up. What is left is x square minus 1 by x power 4. There you take LCM as x power 4. X power 4 into x square is x power 6 minus 1. X power 4 cancels. What you get is 3x square into x power 6 minus 1 divided by 3 into x power 6 plus x power 12 plus 1. Multiply this. I can write dt by 3 from this. Dt by 3. Dt divided by 3 is equal to x square into x power 6 x power 8. Multiply. X power 8 minus x power 6 will get. Dt by 3, x square into x power 6 is x power 8, x square into 1, x square, divided by 3x power 6 plus x power 12 plus 1. Dt by 3 is this. See what is present here, x power 8 minus x square, divided by 3x power 6 plus x power 12 plus 1. This part is dt by 3, correct? Therefore, my integral I becomes I is equal to dt by 3. Whatever is there, this part is dt by 3. Dt by 3 means 1 by 3 keep outside. 1 by 3 integral of dt divided by tan inverse of x cube plus 1 by x cube is taken as t. Dt means 1 dt. Integral of 1 by t is log of mod t. Log of mod t plus c. Which is 1 by 3 log of mod. What is the t you substitute? T is tan inverse of x cube plus 1 by x cube. This I can use the property of log m. N log m is log m power n, right? Using the property of log. n log m is equal to log m to the power n. N can be taken to the power. So is 1 by 3 log of this is log of this to the power 1 by 3. N log m is log m power n. 1 by 3 can be taken to the power as given in option A. Option A is the answer. Is equal to log of mod tan inverse x cube plus 1 by x cube to the power 1 by 3. Option A is the answer. Question asked on 27th of January, second shift, JEE Main 2024. Sometimes it's not possible to identify how to start the problem. After practicing all the many problems and if you know all the formulas and results, then it is possible. Okay, you should be exposed to variety of questions. Then only it's possible to solve any problem. Okay, and a lot of practice is required. You should work out again and again many problems. Thousands of questions you should work out. If you see the PYQs only, there are nearly 3,000 to 4,000 questions of JEE Main. Okay, in the from 2019 to 2025, you see nearly 3,000 or more than that you get number of questions. If you practice that many questions also, it's more than enough. You'll get the idea. Any question is given to you, you'll be able to solve. Okay, so that's the main thing. Learn all the formulas first. Synopsis part should be powerful. Should have a powerful synopsis. Then only it's possible to crack all these questions in lesser time. Okay, move on to the next one. For x belongs to the open interval minus pi by 2 to pi by 2, y of x given like this. Limit x tends to pi by 2 minus y of x 0. Want to find y of pi by 4. So y of x given like this in terms of trigonometry function they're given. I'll go on simplify this. The main idea is how to, I'll reduce it to the standard form. I'll write cosec as 1 by sine, secant as 1 by cos, and tan as sine by cos. Go on simplify it. Integral is given as y of x. Y of x is equal to integral of cosec x, you write 1 by sin x. 1 by sin x plus sin x divided by cosec x is 1 by sin x. Secant x is 1 by cos x plus tan, you write sin by cos. Tan is sin by cos into sin square x. Correct? Cosec is 1 by sin. Tan is sin by cos. Secant is 1 by cos. Take LCM in the numerator and denominator. If you take LCM as sin x, denominator of numerator, 1 plus sin square x by sin x will get. 1 plus sin square x divided by sin x. Here sin x into cos x is LCM. Sin x into cos x is LCM. Sin x into cos x into 1. So this becomes 1 plus cos x to multiply by sin x to get this. Cos x into sin x will give sin x cos x. That sin x into sin cube x becomes sin power 4x. Correct? Cos x to multiply by sin x to get this. That sin x into sin cube x, sin power 4x. Sin x will cancel here. This cos x will go up. Denominator goes to numerator. So this becomes equal to 1 plus sin square x divided by 1 plus sin power 4x. Sin x got cancelled. Cos x will go up. And whenever there is cos x into dx is there, you put t equal to sin x. Cos x into dx is you put t equal to sin x. Method of substitution. Put t equal to sin x. Derivative of sin x is cos x. dt is equal to cos x into dx. Cos x into dx is dt. Sin x is t. So this becomes integral of 1 plus t square by 1 plus t power 4. Cos x into dx is dt. This is very standard one. Quadratic by biquadratic we call. To integrate this, what we do is we divide numerator and denominator by t square. Integral is very standard. 1 plus x square by 1 plus x power 4. Even integral of root of tan x, root of cot x, all these things can be done by this method. So you divide numerator denominator by t square. 1 by t square plus 1 will get. 1 by t square plus 1. Dividing the denominator by t square becomes 1 by t square plus t square dt. I'll write numerator as derivative of which function? 1 plus 1 by t square, derivative of t minus 1 by t, correct? This is derivative of t minus 1 by t. Differential of t minus 1 by t. Because derivative of t with respect to t is 1. Derivative of minus 1 by t is 1 by t square. Denominator t square plus 1 by t square could be written as t minus 1 by t the whole square plus 2. Correct? T minus 1 by t the whole square plus 2. If I expand and simplify, I'll get this. Expanding this, a minus b whole square, a square plus b square minus 2ab. Minus 2 plus 12 cancel, get t square plus 1 by t square. Integral of this time, du by u square plus 2. Integral of du by u square plus 2. Integral of dx by x square plus a square. 1 by a tan inverse x by a. So 2 is root 2 square. It is of the type integral of dx by x square plus a square. Integral of dx by x square plus a square is what? Integral of du by u square plus a square, right? U square plus a square is equal to 1 by a tan inverse of u by a, right? 1 by a tan inverse of u by a plus c. Likewise, this is, so 2 is root 2 square. I can write this as 1 by root 2 tan inverse of t minus 1 by t by root 2. Plus a constant c. Substitute back for t. T is sin x. So I'll get 1 by root 2, 1 by root 2, tan inverse of t is sin x and 1 by sin x is cosec x divided by root 2 plus a constant c. Okay. Now I have to find out the constant now using the condition given there. The given limit x tends to pi by 2 minus y of x equal to 0. So use the condition given. This is my y of x. This is my y of x. Take limit x tends to pi by 2 minus. As x tends to pi by 2 minus, sin x tends to 1, 1 minus 1. Cosec x also tends to 1. As x tends to pi by 2 minus, as x tends to pi by 2 minus, sin x will approach 1 minus. Even cosec x will approach 1 minus. Correct? This almost becomes 1. This almost becomes 1 minus 1 is 0. 0 by root 2 0. Tan inverse of 0 is 0. 1 by root 2 into 0 0. Therefore I can write limit x tends to pi by 2 minus. Limit x tends to pi by 2 minus of y of x. Taking limit x tends to pi by 2. Sin pi by 2 1. Cosec pi by 2 1. 1 minus 1 0. 0 by root 2 0. Tan inverse of 0 0. 0 into 1 by root 2 0. 0 plus c. I'm getting 0 plus c. And limit x tends to pi by 2 minus y of x given to be equal to 0. This part is given to be equal to 0. So 0 is equal to c. The constant c is equal to 0. Constant c is equal to 0. Therefore my function y of x is 1 by root 2 tan inverse of sin x minus cosec x by root 2. Constant c is 0. Now I can find y of pi by 4. So I can add one page. Therefore, constant c is 0. Therefore, my y of x is equal to 1 by root 2 into what we have? 1 by root 2 into tan inverse of sin x minus cosec x by root 2. 1 by root 2 tan inverse of sin x minus cosec x divided by root 2. The value of constant c we got 0, correct? The constant c was 0, so c is 0. Now I have to find y of pi by 4. So put x equal to pi by 4. Therefore, y of pi by 4 we can find out. Put x equal to pi by 4. What we get? 1 by root 2 tan inverse of, here sin pi by 4 is 1 by root 2. Cosec pi by 4 is root 2. Divided by root 2 plus 0 I won't write is equal to 1 by root 2 tan inverse of, take LCM here, root 2. This is root 2 by 1. 1 into 1. 1 minus 2 divided by root 2 is equal to 1 by root 2 tan inverse of what you get is 1 minus 2 is minus 1. By root 2 comes down. Root 2 into 2 is 2. So 1 by root 2 tan inverse of minus 1 by 2. 1 by root 2 tan inverse of minus 1 by 2. Option D is answer. Hope it's clear. Question asked on 29th of January, first shift, JEE in 2024. Okay. Move on to the next one. It is the last question of this session. Covered both January and April shift of 2024 JEE of indefinite integration chapter. Integral of sine power 3 by 2x plus cos power 3 by 2x divided by sine root of sine cube x cos cube x into sine of x minus theta dx. X is the variable for integration. Theta is acting like a constant here. Okay. So what we'll do is I'll separate the terms. Numerator is sum of two terms. Numerator is sum of two terms. No, separate the terms and write. Call the integral as I. I want to find AB. Already the right answer is given in terms of this. I need to find the constants A and B, maybe functions also. So I'll get AB, then find AB, A into B. Okay. So we separate the terms and write. Numerator is sum of two terms. Call the integral as I is equal to, I'll write this as integral of sine power 3 by 2x divided by sine cube x root of sine cube x will be sine power 3 by 2x. Root of sine cube x what? Root of sine cube x. That will be sine cube x to the power half. That will be sine power 3 by 2x. Correct? To the power half. Square root means to the power half. Sine power 3 by 2x. This will be sine power 3 by 2x. I'll write outside sine power 3 by 2x into root of what we have is cos cube x into sine of x minus theta. Root of cos cube x into sine of x minus theta and expanded, right? Sin x into cos theta. Sin x into cos theta minus cos x into sin theta. Dx. Okay. That is, I separated the terms. Sin power 3 by 2x by denominator plus now I'm writing cos power 3 by 2x by denominator. Correct? Plus integral of cos power 3 by 2x divided by, here root of cos cube x will be cos power 3 by 2. Root of cos cube x is going to be equal to cos power 3 by 2x. Correct? That comes outside. Root of cos cube x, I'll write outside cos power 3 by 2x. Taking outside the root. What is left inside the root is sin cube x into sine of x minus theta. Sin cube x. What is sine of x minus theta? Sin x into cos theta. Sin x into cos theta minus cos x into sin theta. So here sine power 3 by 2 cancels. Here cos power 3 by 2 cancels. Correct? And here what you do is, in this bracket you take cos x common. So when you take cos, actually cos x is not common. Still I'm forcibly taking out. Of course you can write sine as a tan into cos. Sine you can write tan into cos because tan is sine by cos. So sine is tan into cos. Correct? Tan x is sine x by cos x. Tan x is sin x divided by cos x, we know this. So sin is tan into cos. So if you write sin as tan into cos, cos x is common. Correct? So sin power 3 by 2x will cancel. Here cos power 3 by 2x cancels. Here I'll take cos x common from this bracket. Here because sin cube x is there, inside this bracket I'll take sin x common. Okay? We'll do this, all those things. This is equal to integral of, this is sin power 3 by 2x got cancelled. Taking cos x common from this, already cos cube x is there, becomes cos power 4x. 1 by square root of, taking cos x common from this, cos cube into cos becomes cos power 4x. Okay. So actually wrote tan, sin as a tan into cos. Correct? Cos x taken out. So what it means? Tan x into cos theta. Tan x into cos theta minus sin theta. here 1 by, here you write cos as cot into sin. You know cot x is cos x by sin x. Cot x is cos x divided by sin x. Cot is cos by sin. So cos is cot into sin. Cos, you write cot into sin. Cot into sin. So that sin x is common. Sin x taken out. Sin x into sin becomes sin power 4x. Root of sin power 4x into sin x taken out. What remains is cos theta. And you wrote cos as cot into sin. Sin is taken out. So cot x remains. Cot x into sin theta. See, I am getting in this form. What is the root of cos theta into tan x minus sin theta? Correct? The right hand side. That is present here. And here, root of cos theta minus cot x into sin theta is present here. I am getting in that form. I should get in that form. Doing the proper method, right method is also important. Not your own method. You won't get the answer. How they have set the question, in that form you should get the answer. Because you should compare with this form, correct? And you have to identify A and B. Then you have to find A, B and the given in terms of all trigonometry functions only, correct? That's the idea. So now cos power 4x there. Root of cos power 4x is cos per x. Cos per x goes up, secant square x. This becomes integral of secant square x into dx divided by root of tan x into cos theta, tan x into cos theta minus sin theta. Here, sin power 4 square root is sin square. 1 by sin square is cosecant square. This becomes integral of cosecant square x divided by root of cos theta minus cot x into sin theta. What we do is, we can use the method of substitution for both the integrals. Here put t is equal to tan x into cos theta minus sin theta. Here put u is equal to this. Derivative of tan x is secant square x. If you put t is equal to this, derivative of this, theta is taken as constant here. So sin theta is constant, derivative constant is 0. Cos theta is constant, constant into variable, constant keep as it, derivative of tan is secant square. So secant square x into dx will be 1 by cos theta into d theta. So you put t is equal to, for this, for the first integral, you put t is equal to tan x into cos theta minus sin theta. So that dt is equal to derivative of tan x is secant square x, cos theta is constant, derivative of tan x is secant square x into dx. Derivative sin theta is 0. Here you put u is equal to cos theta minus cot x into sin theta. So what do you get? du is equal to derivative of cos is derivative of cos theta is 0 because theta is constant, derivative constant is 0. Derivative of cot is minus cosecant square. Minus of minus becomes plus cosecant square x. And this is constant keep as it. Constant keep as derivative of cot is minus cosecant square. So from this secant square x into dx dt by cos theta. Dt by cos theta is 1 by cos theta d theta. Therefore integral I becomes, I is equal to secant square x into dx dt by cos theta. Dt by cos theta means 1 by cos theta. This is secant theta. Correct? Secant theta into d theta divided by root of t. Secant theta dx, not d theta. Dx should be. Dx. I am writing for the dt it is. So no, secant square x into dx I am finding. Secant square x into dx. dt by cos theta. dt by cos theta secant theta into dt. So that this is secant theta is constant, keep outside. Integral of dt by root t is 2 root t. Correct? Same way here. Integral of cosecant square x into dx is du by sin theta. Du by sin theta is cosec theta into du. Cosec theta into du divided by root of, this is u, correct? Integral of dt by root t is 2 root t. Integral of du by root u is 2 root u. Correct? Is equal to how much? Secant theta into integral of 1 by root is 2 root t. 2 root t is what? Substitute back. Tan x into cos theta. Correct? T is what? Tan x into cos theta minus sin theta. Integral of dt by root is 2 root t. 2 root of t, substitute back and write. Cosec theta is constant, keep it outside. Integral of du by root u. Integral of du by root u is 2 root u. So this becomes 2 times root of, what is my u? U is cos theta minus cot x into sin theta. Plus constant c. Okay, so much we got. So compare what is given already. The right answer is given a into root of cos theta into tan x minus sin theta. So a is 2 secant theta. If we compare, I get a is equal to 2 secant theta. And if we compare, b is equal to how much? B is 2 cosecant theta. Correct? Root of cos theta minus cot x into sin theta is there. So b is 2 cosecant theta. So how much is AB you need to find? Multiply these two. AB is what? AB is 2 into 2 is 4. Secant is 1 by cos. Correct? Cosec is 1 by sin. So I am getting AB is equal to 4 secant theta cosecant theta. You can write in the next page. So AB I got 4 secant theta cosecant theta. AB I got 4 secant theta into cosecant theta. Secant is 1 by cos. Cosec is 1 by sin. And you know, cos theta, sin theta is sin 2 theta by 2. 4 into 1, 4. Cos theta into sin theta is sin 2 theta by 2. Because you know, sin 2 theta is 2 sin theta cos theta. Correct? So sin theta into cos theta is sin 2 theta divided by 2. Sin 2 theta divided by 2. This 2 will go up. 2 into 4 becomes 8. And 1 by sin is cosec. So 8 times cosecant 2 theta. That's the answer. A into B is 8 times cosecant 2 theta. Option D. Question answered on 29th of January, second shift JEE in 2024. Please make a note. This type of question is also found in NCERT miscellaneous exercise of chapter 7 of 12th standard integration chapter. Okay, the same type of question is found. Okay, with only one term in the numerator, not 2 terms. That's so you should learn all the NCERT level questions first. Even the miscellaneous exercise exemplar book is also there. NCERT exemplar book. So all the questions, if you solve properly, then it's possible to get hold in the subject. Even Pyq'S, synopsis, NCERT exemplar, miscellaneous exercise of NCERT, each and every problem which should solve. And you should practice more and more. That's the best thing. Okay. So if you practice more number of questions, then only it's possible to crack JEE exams. Maths is very important to get 99 percentile. And attending at least 18 or 19 questions out of 25 will be a good score in mathematics. Okay. So please do make use of these videos. Okay. Subscribe to my channel. Many more videos will be uploaded in the coming days focusing on NCERT exemplar, KCET from 1984 to 2025. That series also will continue. Synopsis for KCET, synopsis for JEE exams, and also Pyq's of JEE exams. All will be covered one by one. All the topics will be uploaded, okay, in the coming days. Please subscribe to my channel and forward to your friends. With this, I conclude. Thank you.